incredibly interdisciplinary. I call myself an organic biogeochemist, so we have biology, geology, and chemistry, and a lot of my work really happens at the intersection of that. And I view carbon cycling on both a local scale and a global scale through the lens of organic molecules, so carbon-based molecules. So why do we care about organic carbon? Well, in the ocean, about 660 petagrams, that's 660 billion tons of organic carbon is in our ocean, and it's roughly equivalent to the amount of CO2 that's in our atmosphere. So if you imagine changing a little bit of that ocean carbon pool, whether it's through natural or human-caused processes, you might impact kind of the balance of carbon in the atmosphere and the ocean, and therefore our planet. And so some of my research has really taken me to the deep ocean, where we find some of the oldest molecules really on Earth. They're certainly in marine environments. And so when you go down to the depths of our deep ocean, there's a certain compound class called condensed aromatic carbon. I'm showing a couple of those cartoon molecules there that was actually drawn by a student of mine as part of a little illustrated zine she put together about this. But down in the deep ocean, it's really difficult to study some of these molecules because they're quite dilute, and also the ocean is very salty, so you have to collect a lot of sample, and it's really difficult to analyze because it's not great for our instrumentation. So we're dealing with a challenge here, but the effort is worth it because what we discovered in going down to the deep ocean and using some compound-specific stable carbon isotope analytical techniques and some other kind of novel techniques, we discovered that, as previously thought, these molecules that comprise a huge portion of our deep ocean carbon pool are not derived from land fires. So these condensed aromatic compounds are formed when you burn biomass, so burn wood, burn grass, things like that. And we thought, based on their structure, that they were coming from terrestrial or land-based wildfires. But the research that I did kind of upended that idea, and so we kind of have to put a little X through wildfires. It's probably not the source of this large pool in the deep ocean, large old pool in the deep ocean. And so kind of building on that work, over the next 3 years, I was recently funded by NSF to actually go down and investigate other sources of this organic carbon. So stay tuned. In spring of 2024, it's scheduled right now. We're gonna go out on an ocean cruise and take Alvin. This is the underwater submersible that discovered the Titanic. So we're gonna go down and sample hydrothermal vents, which is another high temperature source, potentially, of these organic molecules. So we're sort of literally going around the world chasing down sources of these compounds so we can better understand our global